Good morning, all of you. We are discussing about the enzyme catalysis. Already I explained what is the enzyme catalysis. I am giving some examples from this. He asked one CD question in this year. You check it carefully. Already I give an example. You see the third one. It is nothing but starch. Starch is undergoing hydrolysis in presence of. This one only asked in 2020 CD examination. Starch is undergoing hydrolysis. You are getting which one? Maltose we are getting. He asked me which enzyme is we are using here for this conversion. It is nothing but diastase. Diastase we are using. So I will write the equation for this one. Starch means what? Polysaccharide. So many molecules together we are getting a polymer we are getting. What is the formula for this one? It is nothing but C6H10O5 taken n times. Like the two molecules I am taking, and I am taking n number of water molecules I am taking, and in presence of diastase enzyme it will be converting into maltose. Maltose is a disaccharide. Do you know what we are getting means? C12H22O11, but taken how many times? N times. It is a maltose. Maltose is a disaccharide. Will come in biomolecules. Don't worry about this all. And this is the polysaccharide. I will write here PS polysaccharide. This is the disaccharide DS. Okay. Later I will give you one more conversion. The maltose is there, no? The maltose is undergoing again hydrolysis into glucose units. The maltose is purely made up of glucose units. In this conversion we are using one of the enzyme. It is nothing but maltase we are using. Do you know the formula of maltose? Just you take 1 unit, not bulk. Just you take 1 unit C12H22O11 plus H2O. In presence of maltose, it will be breakdown as 2 glucose units. Take here 2,6H12O6. Is it balanced or no? Yes, definitely. 2 units of glucose we are getting. You have to understand the maltose is a disaccharide, is purely made up of glucose unit. You learn sucrose. Sucrose is also disaccharide but made up of 1 glucose unit and 1 fructose unit. And you see some other things, for example, urea. Urea will be undergoing hydrolysis into gives ammonia and carbon dioxide. Ammonia and carbon dioxide. What enzyme we are using here? Urease. Do you know the formula of urea? Already you learned in solutions. NH2CO NH2 will be undergoing hydrolysis. Then in presence of urease, how many ammonia will be forming? NH2 becoming NH3. NH3. How many molecules? 2 molecules of NH3 plus CO and O is becoming like CO2. And one more thing in our body generally happening means this one. Which one? Carbonic acid formation. I told carbon dioxide little bit concentration will be very helpful for metabolism. Did you learn or no? To maintain the blood pH value will be constant. That is calling as a buffer solution. Okay, that is also happening here. You take here what is that one? Water will be combining with carbon dioxide. Then we are getting one of the weakest acid, carbonic acid we are getting. Okay, you take this one in presence of, this is happening in presence of carbonic anhydrous. Carbonic anhydrous. This is the one of the enzyme. I told remaining all over like milk will be converting into curd by presence of lactobacillus enzyme. Careful how to practice, you will get it this one. All of you clear? Yes. Now I am explaining some important information regarding enzyme catalysis. It is nothing but characteristics of enzyme catalysis. Enzyme catalysis means what are the conditions to proceed the enzyme catalysis? First of all, I am telling you it is the highly specific. Enzyme catalysis is the highly specific. What is the meaning of this one? What is the meaning of this one? Specific means what? If you want to proceed means if we take if you take a particular enzyme can catalyze a particular reaction only. What is the meaning? A lot of meaning inside it. If you take any particular enzyme, it can catalyze only particular reaction. Means, for example, you want to do starch decomposition or starch hydrolysis. Okay, if you want to do starch hydrolysis, compulsory which enzyme has to be used? Diastase. Diastase has to be used. Then it will be coming like which one? Maltose. And no sir, I am using starch and water, but take once again, if you take starch hydrolysis, but in presence of zymase, is it work out? No. Just what I am telling you, if you want to proceed this chemical reaction, compulsory diastase has to be used as the enzyme. Means like that every biochemical reaction will have a particular enzyme as its catalyst. That's what we are calling as highly specific. Okay, now I will give you one more thing. Highly efficient. What is the meaning of highly efficient? There's a lot of meaning inside it. Means if we want, or if we take very lesser amount of enzyme can proceed bulk chemical reactions. Did you got? I will explain why. Because okay, highly efficient means if you take a very lesser amount of enzyme can proceed bulk reactions. For example, I will tell you one example. You taken a big tank of milk you taken. You want to convert that one into curd. Are you adding buckets of curd? Means if you want to convert milk into curd, means compulsory we should add lactobacilli. Means you are taking a big tank of milk you are taking. You want to make it as a curd. What you are doing? Just 1 spoon of curd sample is enough to proceed a big reaction. That's why I am telling very lesser amount of enzyme is enough to proceed a big chemical reactions or bulk reactions. That's why we are adding here lactobacilli, very lesser amount of lactobacilli we are adding. Why this one? You asked me 1 or 2 times in a board examination. Why enzyme catalysis is highly efficient? In case of enzyme catalysis, what happening? Activation energy will be very less. If activation energy will be very less, so what? What happening? The gap between reactants and the higher energy state will be less. Then what happening? Reactant is easily converting into products. Then automatically we can tell if activation energy will be less, the rate of reaction in presence of enzymes is almost 10 to the power of 20 times than rate of reaction without enzyme catalyst. If you take this reaction only, you have it diastase. Okay, it will be going very slowly. But if you are taking this one, compulsory the rate of reaction will be how many times is speed up? 10 to the power of 20 times speeder than normal case. This all will be because of in case of enzyme catalysis, activation energy will be very less. That's why the whole reaction will be going very speed as well as very fast. Means gap is very less. This is going with high speed. And I want to tell some other things is nothing but optimum conditions. Okay, optimum conditions means what? Favorable conditions. For example, imagine our body only. Okay, we can tolerate up to 25 to 35 degrees Celsius temperature. If it is crossing 35 degrees Celsius temperature, we are feeling uncomfortable. Why? At that high temperature, our body functioning will be disturbed because of enzymes are not working properly. That's why what are the favorable conditions for the enzyme catalysis means I am writing optimum temperature. Optimum is what? Suitable or favorable. Suitable temperature for enzyme catalysis is around 25 degrees Celsius to 37 degrees Celsius temperature. Yes, if it is for example 15 degrees Celsius temperature is there, we are feeling cold, means then we are getting some health issues. Are you getting health problems or no? Like cold and cough? Why? Because our body function will be disturbed. No, you take you are going very heat areas like 50 degrees Celsius. There also what happening? Enzyme catalysis will be disturbed. Then we are facing some health problems. So 25 degrees means indirectly nothing but 298 kelvins to how much? 310 kelvins temperature. What is the optimum pH for enzyme catalysis? Optimum. Yes, imagine our body pH value only. Our body means is nothing but blood pH value. What is the blood pH value? Has to be maintained 5 to 7. Slightly acidic value or neutral. If it is very acidic or very basic, what happening? The whole body functioning will be disturbed. To maintain this pH value range, which is useful, carbonic acid. Like a buffer, weak acid and its salt is acting as a buffer to maintain the blood pH value will be remains same. All of you getting on? These are optimum conditions. Still, I want to tell some other information related to characteristics. It is nothing but activators. Activators. Just you see, what is the meaning? In the main answer is there. Activators. Activators means they will some of these substances are chemicals. Some of the substances will increase the rate of enzyme catalysis. Rate of enzyme catalysis. Enzyme catalysis, like indirectly promoters. They will increase the action of the enzymes in the reaction. Automatically, whole reaction speed will be going on increasing. Those activators are of two types. The first one is nothing but coenzymes. I think in biology you learn this word, coenzymes. Along with enzymes, some part will be there. It will affect the arm speed of the whole enzyme catalysis. Coenzymes means indirectly nothing but non-protein part in our body. Non-protein parts. Which are non-protein part in our body? Vitamins. Means if vitamins are in sufficient quantity, what happening? The whole enzyme catalysis will be speed ups. And I want to tell one more activators is nothing but activators only. Activators. Generally, which are acting as a activators for whole enzyme catalysis means is nothing but metal ions, minerals indirectly. Minerals is also plays very important role in the speed of whole enzyme catalysis. Do you know which metal ions is very important for our body functioning? Sodium ions, as like manganese, Mn+2, and as well as copper. Now in ROs also we are using nowadays copper coil and our copper vessels, copper glasses. These all are because a little bit copper is also very important for whole metabolism. Indirectly they will show effect on speed of the enzyme catalysis. Like that, cobalt +2. I told already cobalt where it is present. It is present in vitamin B12. Is a central atom in the vitamin B12. Vitamin B12 means cyanocobalamin. I told already in the first year its name. It is present in vitamin B12. These all are very helpful to increase the speed of the enzyme catalysis. Already we know one more problem. It is nothing but poisons. Yes, everything should be under control. Whether whatever, if you take in our daily life also, money should be under control. If money is more, we have to face the problem. Money will be the very less, which shortage. Then also we have to face the problem. That's why everything should be under limit. Okay, but what happening? For example, one enzyme catalysis is going. It's going with high speed, danger. It's create health problems. That's why what we have to do? We have to slow down that enzyme catalysis. Then what we should do? Poisons we have to use. Poison is not like that. Means they will only act on speed of the enzyme catalysis. It will slow down the enzyme catalysis. Then everything will be under control. Then our health issues will be clear. Okay, what will be acting as a poisons? How they will be acting? So generally, heavy metal ions are acting as a which one? Poisons. What heavy metal ions? Do you know? In d block element last two groups, silver and mercury. Silver means Ag plus, and one more is nothing but mercury is nothing but Hg+2. These two are acting as a poison. So how they will control the speed of the enzyme catalysis? For example, enzyme is there. Okay, on this enzyme what will be there? Some active centers will be there. Okay, then what happening than the normal? Here it has more number of active centers. Then what happening? More reactive particle going sticking here. The whole process will be speed up. Then what we are using poison we are using either Ag plus or Hg plus 2 mercuric ion. What they will do? They will be sticking on this active sites. They will close that active sites. Then the reactive particles sticking on that enzyme will be less. The whole process will be slowed down. Like that, poisons means metal ions, heavy metal ions is acting as a poisons means they will slow down whole enzyme catalysis process. All of it here is also very important concept. Now we are discussing about the mechanism. Is important for board exam. Mechanism of enzyme catalysis. Enzyme catalysis. What is the mechanism of enzyme catalysis? Is like heterogeneous catalysis mechanism is also important for theory. You can see. Okay, I will explain as it is right now. First of all, I am taking enzyme. Enzyme I am taking. That enzyme is denoted by letter E. Okay, it is similar to key for a particular lock. Okay, then we are taking, it will be involved in the reaction with which one? Substrate. In enzyme catalysis, we are using one more new word, substrate. Actually, substrate means it is nothing but a reactant. It is nothing but a reactant. The substrate is denoted by S. It is similar to like lock. That's why the enzyme catalysis mechanism is also calling as like key lock mechanism. Yes, now I think you got in biology this concept. Okay, in the enzyme catalysis we have enzyme, it is similar to key, and substrate is there nothing but reactant denoted by S, it's like a block. So what happening here? You see carefully. First of all, I am taking the enzyme, I am taking like a key having a particular shape like this will be there. Observe very carefully on enzyme. Okay, it is involved in the reaction with which one? Reactant, indirectly nothing but substrate. It will be like this. It is denoted by S. Now, it has to be converted into product in presence of enzyme, that will be nothing but like a key. Okay, what happening between them? Observe very carefully. In the enzyme, one active site or active center is there. Yes, it is nothing but active center or active site. So what is this active center or active site? It is favorable or it is suitable for the adsorption. Why? First of all, you come to this point. Enzyme is what? Protein. Yes or no? Is it correct or no? The proteins which are acting as a catalyst for biochemical reaction is specially called as enzyme. So anyway, enzyme is nothing but protein. Protein is made up of amino acids. It's a combination of amino acids. So you know, in amino acids, which function groups will be there? We have so many amino acids. Its biology it will be coming around 24 amino acids we have. In that commonly appearing function groups are NH2 and COOH, amino group, carboxylic acid group, and OH group, and also thioalcohol SH. These groups will be lying on the surface of the enzyme. Those groups only we are specially calling as a active site. Then what happening? The shape and size of the active site in enzyme should be suitable or should be same as in substrate. Then what happening? This enzyme will fit into that substrate. Then we are getting one of the intermediate enzyme substrate ES complex we are getting. ES complex. Enzyme substrate complex we are getting. How it is I will explain to you, see carefully. You take like this, will be there, key will be there like enzyme. Here what will be coming? Substrate will be there. Yes, you take into one another. Then what happening between these two? What happening? Adsorption is going on. In between enzyme and substrate, adsorption is going on. Under adsorption, what happening generally? Energy will be releasing. The releasing energy is only act as a activation energy. Then what happening? You already know under enzyme catalysis, activation energy will be too small. That's why with that energy, the substrates or reacting particles are going into activated state, undergoing effective collisions and converting into products. Means then what happening? This complex is highly unstable. Highly unstable. Why? Because the system has more energy. More energy means activated state. More energy is always danger. Highly reactive, less stable. Immediately decomposing like how? Enzyme and products. Again, what happening? Key will be coming as it is, yes or no? Or written as it is like this only. Enzyme and as well as products durability. How it will be breakdown? I will write it here. See carefully. Again, key will be reformed as like original enzyme, but the substrate particle will be breakdown into products denoted by P. This is the important information regarding enzyme catalysis, and sometimes is asking under enzyme catalysis mechanism in between enzyme and substrate, what type of attraction will be going on? Anybody? Observe here. In all these particles, highly electronegative element is there, nitrogen is there. Between them, other than SH, remaining all groups are having a capacity to form hydrogen bonding. Very good. In case of EX complex, which bonds forming between enzyme and substrate? Hydrogen bonds will be forming. Is it strong bond? No. Very weak attraction. Bond is what? There is no covalent bond. Just attraction will be happening between adsorbate and which one? Substrate and enzyme. Yes, with that adsorption, energy will be receiving, going into activated state and converting into products. Again, key will be coming back and converting into products. So it is also best evident. Just once again you see the enzyme catalysis mechanism is also calling as a key log mechanism. How we compared? Enzyme is similar to key and substrate is also nothing but reactant is similar to log. Yes, you take one simple example. I told her it is highly specific. Means a particular chemical reaction catalyzed by only a particular enzyme catalyst. If you can exchange them, no use. Simple example. You take this room lock and key. Yes, you take this key and you want to open that room lock. Is it possible? Should not. Are you understanding or no? That's why it is calling as key lock mechanism. Every lock has a particular key for that particular lock. Like that, every chemical reaction has a catalyst like enzyme. For that, it will be special. We can exchange them, no reaction for that one. Very simple. First of all, you have to take the enzyme. Enzyme will be similar to a key. On it, enzyme, some active sites will be there. Indirectly, nothing but enzyme is nothing but protein. Protein made up of amino acids. Amino acid is there, amine group is there, carboxylic acid is there, alcohol is there, thioalcohol. In alcohol, O is replaced with S. That's calling as thioalcohol. Like these groups will be there. Okay, it is we have substance. Here condition is what? The size and shape of enzyme should be same size and shape of active site in the substrate. Then that enzyme will be fit into that substrate. Then energy will be releasing. The releasing energy used for the process as activation energy. Then with higher energy, they will do effective collisions and converting into products. Once it breaks down, again key will be normal. When it comes to starting, the process will be going a cyclic way. Are you clear? Yes. Now we are discussing a lost concept, a little bit used concept under surface chemistry. Adsorption phenomenon is over, catalysis is over. Now last topic is colloids. Very important concept. Colloids. Yes. What is this colloid? New word for you, but you know already some idea regarding this one. The colloids is introduced by one of the great scientists, Graham. Where we learn regarding Graham? Graham's law. Under states of matter, Graham's law of diffusion. The rate of diffusion is inversely proportional to square root of density of the gas. There we did so many things. Let it be. The colloids concept is introduced by Graham's. What is this colloids concept? For example, I am taking a substance A. Observe very carefully now. Substance A is mixed with another substance B. Another substance B. Okay, if you are mixing two components, then what we are getting? Mixtures we are getting. Whether homogeneous or heterogeneous or let it be. Mixtures we are getting. Those mixtures will be three types. How it is I will explain. A first category is nothing but crystalloids. Crystalloids. The crystalloids means indirectly true solutions. Already we learned in second topic. Crystalloids means is nothing but true solutions, means is nothing but normal solutions, nothing but homogeneous mixtures. Now another category is our concept. It is nothing but colloids. It is also calling as sols. Colloids is also calling as a sols. And another one is suspensions. What is the meaning of suspensions? Pulp particles. Indirectly in our words we can call it as precipitates. These all will be classified based on which factor? Based on, for example, A substance is dissolving in B substance. Then this classification based on size of dissolving particle. Size of dissolving particle. Did you got my point? Based on size of the dissolving particle, the resultant mixtures will be classified into three types. Nothing but crystalloids, nothing but true solutions, colloids, also calling as a sols, and suspensions, also calling as a precipitates. I will give the clarity for you. First of all, you have to discuss about the crystalloids. Here you will get the clarity regarding three different mixtures. Another one is colloids. Another one is suspensions. Nothing but precipitates. By seeing these differences, you will get full clarity regarding colloids. Okay, this whole classification based on which one? Size of the dissolving particle in another medium. For example, here first point I am telling. In case of crystalloids, size of dissolving particle. Size of dissolving particle is equals to or less than 1 nanometer. What is the meaning of this one? Particle size, the particles which are dissolving in another medium should be very small, denoted by like one full stop. But comparatively here what happening, you know, here dissolving particle size will be 1 to 1000 nanometer. Is it bigger than crystalloid or no? Yes, definitely this size will be this much. Okay, if you take suspension, what happening in this dissolving particle size will be too much. Yes, precipitate you can take. Precipitate means you are feeling that precipitate why? Particle size will be too big. That's why here dissolving particle size will be more than 1000 nanometers. Sometimes he is asking in picometers also. According to that we can convert that one. It's not a matter. All of it clear? Means we have three different types of the mixer: crystalloids, colloids, suspension. Crystalloid means in that dissolving particle size will be too small, like less than 1 nanometer. No, if the dissolving particle size is 1 to 1000 nanometer, little bit bigger than crystalloid is calling as colloids. No, dissolving particle size is too bigger, then it is calling as a suspensions or indirectly calling as precipitates. Now my question, second point, is it homogeneous or no? It is also calling as a true solution. This is calling as a sol. This is calling as a precipitate. Now I am asking the crystalloid is a homogeneous or heterogeneous? Particle size is too small. No, if you can mix that one, we can identify them. We can't identify them. That's why we are calling as a homogeneous mixture. The crystalloid means is nothing but true solution. True solution is what? Homogeneous mixture. It is the homogeneous. Is it? Colloid is not a homogeneous. Why? Because its particle dissolving particle size will be little bit bigger. That's why by using microscope we can feel them. That's why it is calling as a heterogeneous mixture. Heterogeneous mixture. It is very clear. It is definitely heterogeneous because particle size is too big. Heterogeneous. Are you getting or no? Yes. Next point I want to tell. Is it possible to see those dissolving particles with naked eye? No. By using any device? No. Means not visible. The dissolving particle is not visible. So we are discussing about the dissolving particles. Dissolving particles are not visible. But here, yes, but by seeing we can't feel, but by using microscope we can feel them. That's why it is calling as visible, visible with the ultra microscope. ultra microscope. Okay, here just is it requires any device? No, that's a very clearly